What you're looking at is a small AMD mini PC. No discrete GPU, no NVIDIA hardware anywhere in this box. Just the built-in integrated graphics. In this video, I'm going to train a machine learning model on this device. Here's the part that still makes me smile every time. When I run torch.cuda.is available on this machine, it returns true on a system with absolutely zero NVIDIA components. That's ROCm. What's happening here? That's AMD's software stack sitting on top of the hardware layer that answers to the CUDA API that PyTorch expects. And the best thing, the setup, zero steps. I'm just using Arch Linux, which ships with ROCm support in the official repos. I just installed PyTorch straight from the official download page on pytorch.org. There's no builds, no custom downloads, no Docker gymnastics, no patching, just UV pip install, and the iGPU is ready to train. So in today's video, I'm going to answer of how far can we push the actual training of machine learning models on the integrated graphics card. Let's find out. So we are here in the terminal, and the first thing we are going to do is to install PyTorch with the ROCm backend. So for that reason, we are just searching for PyTorch. Go to the main website, get started. Here we have the latest stable release for Linux, pip, and we select ROCm. Copy. Next up, we're creating actually a new virtual environment with UV. Next up, we're going to load this virtual environment. We are running UV pip instead of just pip install. And now we will download Torch with the ROCm backend. This may take a while because I think it needs to download the binaries and everything. So yeah. All right, so install is done. Next up, I want to install a thing called IPython. Install a thing called IPython. Because this is a REPL read, execute, print loop tool where you can just play around with. So next up, we're going to import Torch. And we run torch.cuda.is available. And this returns true, so we have CUDA on our system. However, if you go out and run NVIDIA SMI, there's no NVIDIA GPU here. If you run ls CPU, we'll see that we have an AMD Ryzen AI 9 HX370 with an integrated GPU here. So you don't have any physical GPU, not NVIDIA, not even AMD, anything discrete graphics card. We have just an iGPU here on an AMD mini PC here that supports PyTorch, and it returns, yes, CUDA is available. So this is really amazing. So I have here a script called train mnist. So this is a very simple, small convnet, a couple of layers and so on. And specifically has only one argument. For a CLI argument is a device. So we can either have CPU or CUDA. Does normal train it, trains for 10 epochs and so on. So I just want to show you this script in action. Train mnist. Let's start with, we train on CPU first. So this just trains a small mnist network on the CPU that we have here. All right, so it trained for 3 epochs now. It's still training actually, but let's cancel it. So we see that it takes around 19 to around 20 seconds per epoch of training when we run this on CPU. But let's show you what happens if you run this on CUDA. So basically the PyTorch device CUDA. Keep in mind again, like this has no NVIDIA graphics card. It does not have even a discrete GPU of any type in there. So again, it ran for now four epochs, and first epoch took also 19 seconds, but all consecutive epochs, so epoch number 2, 3, and so on, takes only 10 seconds, so half the time it takes to train on CPU. And yeah, so this is really interesting. So it's not just, a device that's like, reports it has CUDA available, but it's the same thing, it's the same flops compute budget available, but this actually unlocks more flops and more compute using the integrated graphics card on this device here. So it's really great news for machine learning researchers and developers because they can write, run, and test CUDA level PyTorch code locally on the integrated GPU. The question is, what models are you going to train on your integrated graphics card?